Okay, so you see a question like this on an exam paper, right? At first glance, it's just a bunch of weird symbols and conditions, and it can look pretty intimidating. But I promise you, once we pull it apart, it's actually just a fun logic puzzle.
And that's exactly what we're going to do. In the next 5 minutes or so, we're going to walk through this entire thing together piece by piece. You're going to see just how simple it really is.
So let's get started. Think of this less like an exam and more like we're cracking a code. And the first rule of cracking any code is you have to understand each piece of the puzzle before you try and put it all together.
And the very first piece is to map out our number universe. Basically, we need to know the world we're playing in. What are the rules? What numbers are we even allowed to use for this problem?
The question gives us this, the universal set, represented by that Greek letter mu. It says mu is all integers x, where 1 is less than x and x is less than 20. So what's that in plain English? It just means all the whole numbers between 1 and 20. So our playing field is every integer from 2 all the way up to 19. That's it. That's our entire universe.
Now let's define our first team, set P. The rule is that it has all the multiples of 3 that live inside our universe. So we just run through the 3 times table, right? 3 times 1 is 3. Yep, that's in our universe. 3 times 2 is 6. 3 times 3 is 9. And we keep going all the way up to 3 times 6, which is 18. Now, if we tried 3 times 7, we'd get 21, which is outside our universe, so we have to stop at 18.
And there we go. The complete roster for Team P is 3, 6, 9, 12, 15, and 18. These are all the multiples of 3 that exist within our special universe. Simple as that.
Next up, set Q. This team is made up of all the prime numbers in our universe. Quick refresher, a prime number is any number bigger than 1 that can only be divided cleanly by itself and 1. So we just scan our universal set from 2 to 19 and pick them all out. That gives us 2, 3, 5, 7, 11, 13, 17, and 19. Perfect. Our 2 main sets are now totally defined.
All right, let's get to our first challenge. We need to find P intersect Q prime. Now, I know that looks complicated, but it's really just 2 simple steps. First, we have to figure out what on earth is Q prime.
Well, this little apostrophe is the whole secret. It's called prime or complement, but it simply means everything that is not in the set. So Q prime is just a fancy way of saying every single number in our universal set that is not a prime number.
And this is what that looks like. We take our entire universe of numbers from 2 to 19, we kick out all the primes that were in set Q, and this list right here, that's what's left over. Those are the members of Q prime. Okay, now for the second step, that upside-down U symbol means intersection, and all it's asking is what numbers do these 2 sets have in common? We just have to look at our list for set P and our new list for Q prime and find any numbers that are on both lists. Go ahead, see if you can spot them.
If you spotted 6, 9, 12, 15, and 18, you are absolutely right. Those are the only numbers that appear in both of our sets. And just like that, we've solved the first part of the question. Challenge 1, complete. On to our second challenge, finding P prime union Q. Again, it sounds tricky, but it's the same idea. It's a 2-step process. First, let's figure out P prime, and then we'll deal with that union symbol.
Just like before, P prime means everything in our universal set that is not in P. So we take our big list of numbers from 2 to 19, remove all the multiples of 3, and here is what's left.
Now what about that U symbol? This is union, and it's the friendly opposite of intersection. It's not looking for what's common, it just wants to combine everything from both sets into one big superset. The only rule is you don't list the same number twice. So when we merge P prime and Q, we get this giant list. We take all the numbers from P prime, and then we add any from Q that weren't already there. In this case, that's just the number 3. And that's our answer for part B. 2 down, 1 to go. All right, here we go, the final challenge. This one has parentheses, which in math is always a giant clue. It means do the stuff inside the parentheses first. So our job is to first find the union of P and Q. Then, and only then, we find the complement of that entire result. So, step 1, let's combine set P and set Q. We're doing a union, so we're just making one big list with all the unique numbers from both of those sets. When we merge them, this is the set we get. Notice how the number 3 was in both of the original sets, but we only list it once here.
So this combined set is our answer for what was inside the parentheses. But we're not done yet.
The final step is to find the complement, that's the little prime symbol again, of the entire set we just created. So we ask ourselves, looking at our big universal set, which numbers are missing from our new P union Q set?
And the answer is right here. The numbers 4, 8, 10, 14, and 16. They are the only ones from our entire universe that were not in the union of P and Q. And with that, we have solved the final part of the question. We did it. So there you have it. We took a question that looked really complex on the surface, and we just broke it down into a series of simple, logical steps. We defined our world, we identified our teams, and then we performed these clear operations: intersection, union, and complement.
But honestly, getting the right list of numbers on the page, that isn't the most valuable thing you just learned how to do.
The real prize is the thinking process itself. This ability to define a universe, to categorize things into groups, and then to analyze the relationships between those groups, what they have in common, how they combine, what's left out. That is a superpower that you can use to solve problems far beyond any math exam. The only question is, where will you use it next?